Hey, what's up, guys? Hey, so today we're going to go over all the design work on this American Wavy flag. We're going to do a couple different versions. We're going to use AI to generate a really cool model, but then we're going to take that model, modify it within Blender, and then get it into Fusion 360 to do all the design work, down to the CAM toolpath generation to where you can actually get this on your CNC. It's going to be a lot. I'm going to go very quickly. So if you need to hit the pause button, definitely do, and then just kind of catch up. This file will be available on my Patreon. So if you want to sign up and download it, definitely do. But so the overall concept of this 3D inlay is we're going to try to get to this point, right? Where you have two different pieces of wood and then a 3D model, and then it's going to be inlaid within the actual base material. That's the overall goal of this, and so we have a lot to go over. Let's get started. Okay, so we're going to jump right into Fusion 360, where this is where we're going to do all of our design, modeling, and our toolpath generation. Before we get started, though, I need to understand the dimensions that we're gonna work off of. So here's a link. It'll be in the description to this calculator. It's super awesome. So to understand the placement of the stars, to the union, to the width of each stripe, and then the overall dimensions of the flag, this is the tool that I use to generate that. I like to use 1-inch stripes. It's a pretty large flag, so it's going to be 13 by 25. I usually round up just to make it a little bit easier within the design environment, working with whole numbers. From here, I can round up for the union width and length, and then also the stars. So knowing this, let's jump back into Fusion 360, and let's go ahead and we'll create a new sketch. So from here, we'll use the rectangular tool. We'll do a 13 by 25. And if you noticed, I made sure I clicked within this center point of the actual coordinate system. This is very, very important when you start exporting and importing different things. But we want to make sure we do that. So I'm going to hit enter on that, and then let's apply some thickness to this. Now, the thickness is all dependent on the materials that you have in the garage. I use 8/4, and then I plane that down to 1 3/4 inches. So I'm working with very dimensional lumber. It makes it a lot easier when I get into the actual garage. So if we're going to design this, I'm going to put 1.75, and I'm going to do a negative to keep it below this coordinate system. I'm going to hit enter on that. And then from here, I'm going to go ahead and I'm going to import the wavy flag profile, and then we're going to manipulate this body. The wavy flag profile, that will be included in the file, and you can take that into any other software. It's an STL, it's all dimensional, it's everything that you're going to need if you want to go outside of Fusion. But so from here, let's go ahead and we'll import this. We'll do insert mesh, and then we'll find that wavy flag profile STL. I'm going to double click on that, and it's automatically going to place it exactly where I designed it off of. That's why using that coordinate system is really important when you start working with some of this stuff and you export it. So with that, it's already good. It's already within here. If for some reason it's not, you can go ahead and you can move it and all that other stuff. We'll keep it exactly where it was imported from. If it looks different than this, say if you accidentally had millimeter as a unit type and it looks like this, all you got to do is change it back to inch and it'll bring it right in. Okay, so we'll hit OK on that. And so with this, I cannot modify this body with this mesh STL. They're two incompatible things in Fusion. So I have to convert it. To convert it will depend on the version of Fusion that you currently have, whether that's the paid version or the free version. I currently have the paid version, so I can convert this into an actual an object file that I can use to modify other bodies with. To do that, let's go ahead and go to mesh. We'll go to modify and then convert mesh. We'll select that mesh, and then I have a couple options here. The paid version, you won't be able to use prismatic. This is what we want to use. If you have the current free version, I will include the conversion to this profile so you can actually do it inside the file, okay? Do not use faceted within this tutorial. Later on within the walkthrough, it's not going to work. When we start doing the actual VCarve inlays, it's just not going to calculate it. It's going to be too painful. Okay, so I'm going to go ahead and I'm going to convert it. And while this is going, I'm just going to go ahead and fast forward. Okay, so it just finished up. you can see that now I'm not working with a mesh, I'm actually working with a surface, and I can interact this surface with this body. So I'm going to unhide the body, and then I'm going to use the split body tool, and I'm going to select the body to split as this body 1, and then I'm going to use the mesh as the actual splitting tool. From here I'm going to hit OK, and then what it's going to do is it's going to divide this body into 2 segments. You have the bottom and the top. I don't need the top anymore, so I'm going to go ahead and remove that. Always remove, do not delete. When I remove, it got added into my history. That's very, very important when you start modifying. Say if I modified this sketch, if this doesn't have a point of reference to remove it, it's going to fail. Okay, so I'm going to hide the wavy flag profile, and this is the actual body that we're going to use to manipulate everything within this environment. Okay, so the next critical thing is let's go ahead and pull in the actual stars and we'll get in place. So I've already made the drawing file for this, and it's automatically constrained within this work surface. So from here, let's go ahead and we'll insert drawing. I'm going to use this plane as my reference point, and then I'm going to bring in the 50 stars original drawing file. And so this drawing file, all the points are very constrained, and this works really, really well with like a V-bit. It looks really, really good, and you can constrain it really, really well. From here, I'm going to hit OK, and that is my drawing for all the stars. I'm going to use this as a critical reference point when we start making the mesh for the star. This drawing will be a little bit different than what we're going to generate. So with that being said, let's go ahead and let's pull up VistaScuplt. But first, let's go ahead and pull up their website. So VistaScuplt, this link will be in the description along with a 30% discount code. If you choose to download it, try it out. I've been using VistaScuplt for about 3 months now, just kind of playing around, generating different models. And I can tell you that the quality of the models are pretty much second to none. I know Vectric, they just published their version of their AI generated models that's integrated within Vectric. I don't use Vectric. So this is a little bit easier for me to transition to and get quality models that I can manipulate and do other things with. Not only does it generate images and models, you can do depth maps, you can do image to vector. There's a whole laundry list of different options. If you have time, definitely check it out. But we're going to use this program to generate that 3D star. From here, you can go to download. You can actually use it. The pricing is all within the website. They have a lifetime subscription where it's a pay once, or you can dial it back down to 1 month, 3 month, or 12 months. Currently, I have the 3-month version. I went ahead and paid for it. It gives me 200 free credits. Credits are used to basically pay for the AI generations because it reaches out to a different server, all that good stuff. Like, play around with it. It's definitely worth it. And let's go right into it. Okay, so this is the user interface for VistaScuplt. And there's a lot of things that are happening here. You can control your scene of things that you generated. You can manipulate, you can model, you can smooth, you can edit that model. You can do scaling, you can do a whole laundry list of things. On this side is where you start generating what you want. This is not going to be a complete walkthrough of VistaScuplt. We're just going to use this to produce a star that we can take into Fusion. So we have 2 different options here. We can either reference an image that we found online, or we can have AI generate an image for us. Let's use AI to generate this, and you can see my credits, and just pay attention when I start doing this, where you can see these credits start to tick down just a little bit. I have generated a lot of things within this, different variations. You can see I did my tough leather within this environment. But yeah, so let's go ahead and use this. So what we're looking for is a 5-point star that is embroidered. It helps if you spell everything correctly. Let's go ahead and we'll just generate this, and let's see what this populates. Okay, so this is the image that it generated. It cost me a couple credits to do it. I think it still looks good. My other generations looked a little bit better. I want to have a lot of definition and I want to make sure it looks like cloth. So this generation was really, really good. You can see the shadows under here and it'll give it a lot of depth. So let's actually use this one instead of the one that it generated just now. Not a whole lot of difference, just a little bit of deviation. So let's use this. And what I don't want is I don't want the background of this image. So I can actually go in and edit and I can remove that background. And then it will warn me, hey, it's going to use AI to remove the background. It's going to cost me 1 credit. Still processing. Honestly, this is pretty quick. The other AI systems that I use, I mean, it takes a good portion of it. So this is pretty quick. Let me go ahead and apply this. It removed the background perfect. And then I'll exit out of this. And then from here, I can control the amount of detail within the actual image that it created. I'm going to increase the depth just a little bit. Let's go ahead and we'll just smooth the edging just a little bit. And then for the quality, I'm going to put it as ultra. And then let's go ahead and generate this 3D model. Now, depending on if this is the first generation of this image, I've actually done this image at just a handful of different times, so it's going to be a little bit quicker than what it would be. Usually it goes anywhere from 20 seconds all the way to a minute. So this should go right around 25 seconds. We'll see what it does. So not bad. So this is the 3D model that it generated based off of this image. And I have the option to control the detail a little bit more if I want. And then I can accept this model from the preview model. So let's go ahead and we'll accept it. And then from here, I can see what my actual scaling is. So right now, this is about 35 by 32 inches. This thing is huge. If I go back to Fusion360 and I can understand the overall distance of my star, let's just go ahead and we'll edit this sketch really quick. And let me just draw a line from this. So, you know, I'm right around 0.72 as far as the total length. For the width of this star is going to be right around 0.75. So I'm going to use those to get it kind of close on what I need. We'll go ahead and just finish sketch. Don't need that. Let's go back to VistaScuplt, and what I can do is I'm going to click this aspect ratio, and the overall length, let's just say 0.7. We'll enter on that, and it will automatically scale this mesh to that dimension. I want it just a little bit thicker. 0.08, about a 1/16 of an inch is not a really, you know, that's not a lot of depth. So actually, let's do 0.72 for the actual height. I think I did that backwards. So let me uncheck aspect ratio, and then let's put this to 0.125. So you can see it's automatically scaling it, and I have the control to manipulate. I can make this a little bit, you know, more high in its height, or I can play around with the length where it's not controlled with the actual ratio of the star model. I can actually use these tools to go through and modify a couple things. Say if I don't like the height of this portion, I can actually drop that down. So I can do depth optimization, and I can go in and I can control this height just a little bit more. So instead of a big point like that, I can bring it down. I actually do like the height of this. So I think I really don't have to modify anything with this. So I am really happy with that generation. And so let's go ahead and we're just going to export it. Okay, before we actually export, it's really important to note we need to distinguish between a VistaScuplt model versus a Fusion generated model versus, you know, Blender when we start going into this. So I'm going to make sure that I identify that this is the original star from VistaScuplt. So I'm just going to do VS_star. When I save this, I can go through some extra prompts here. I can have a target polygon count based off of this model, and I can optimize that to make that count. So I can increase this all to basically 3 million polygons, or I can dial it back just a little bit. I'm going to leave it defaulted, but I'm going to uncheck this closed bottom. I want to keep the bottom open. That closed bottom, to make it solid, that's more of 3D printing type operations. I'm just going to keep it open. So from here, I'm just going to hit OK. And then I have successfully exported that 3D model. So between the generation to the actual model to modifying it, it's actually really, really quick. That's probably the best feature that I have with VistaScuplt right now, other than the quality of the models. So technically we are done with VistaScuplt, and we're going to transition back to Fusion360. So let's go ahead and insert that AI generated model from VistaScuplt. And you can see that when I imported it, that scaling that I put in, it didn't keep it. And this all has to do with the unit type. And I still, I'm unsure whether that is a bug within VistaScuplt or if it's a bug within Fusion360. But if I put this to millimeter, it is the dimension of what VistaScuplt actually produced, even though I exported it under inches. So it's a little bit of funkiness going on. I'm unsure who the actual culprit is, but if you notice that difference, that's how to get around that. So I'm just going to go ahead and place this star really, really close on where I want it. And you can see that, the original sketch, this model is not fully dimensional based on that. When I created the sketch, these are dimensional 5-point stars, right? I can get that center point directly in the middle of this. So it's a little bit out of whack on what I would like. I would like VistaScuplt to be able to, control this 3D model that it generated inside these vectors. That would be a really cool feature that hopefully they implement at some point. I think it would definitely help me out. Okay, so I like the placing. Let me just make sure that this thing is actually centered within the sketch, because I want to use this as a reference point. Let's go ahead. I like the scaling. It's within parameters. I like it. I'm going to hit OK. Now, the next thing that we're going to do is I cannot VCarve inlay this star, this mesh, against this drawing. If I was to use this material, it's out of whack, and I wouldn't get the definition and the really cool texture. It just wouldn't carve correctly. So what I'm going to do is I'm going to hide the 50 stars original sketch, and then I'm going to create my own vector along this profile. I wish there was an easier way of doing this. Right now, this is just the reality of it. But this is my reference point model, so I'm going to go ahead and create a sketch. I'm going to use the same plane that I've been using, and then I'm going to go ahead and I'm just going to draw the vectors around this image. So it doesn't need to be exact, but I want to make sure that whatever line, it's within this mesh. I don't want to be on the outside of it. And then I can control this corner a little bit easier. So I'm just going to stop short of that corner and then modify that later. So from here, I'm just going to make sure my lines are all within these parameters. I'm going to go kind of quick, so it's not going to be perfect, but that's okay. To close this, I'm just going to hit exit, and then I'm going to go back to my line, and then I'm going to go right back into the next line. And we're just going to keep going around this outline of this model. And again, man, I wish there was a faster way of doing this. But again, if you guys know a way, definitely leave that in the comments. All right, let's keep going with this. And all we're doing is just this line that I'm putting in is what I'm going to reference when I VCarve. So if I'm outside this line, it's not gonna VCarve the actual model because there's just not going to be material there. So it is quick, but still kind of a pain. And then you'll notice, I'm going to replicate the star, the mesh. I'm going to multiply that by 50. But again, it's this is the current workaround, and then we'll see if there's maybe like a better optimized method of doing this. Okay, so now what I'm going to do is I'm going to use the fillet tool, and I'm going to use this to do this corner. And we'll stop it right about there. I'm going to hit enter on that just to save that dimension. And I'm going to do the same thing for this corner. All within keeping it, like this is not an issue, right? But it would be an issue here because the base material that we VCarve into and we add material here, when it does this profile of this mesh, you're going to have a flat spot here. So we'll leave it like that. I'm going to hit OK on that. I'm going to do all the outside corners first, and then we'll do the inside corners. And, you know, you can, we'll get to that. We can leave it as a sharp point here, or we can put a nice little edge on it. All right, a couple more left. Let's get it pretty close. Hit OK on that. I like it. Okay, now let's look at these inside corners. Now I can leave them this hard edge, or I can put a fillet on. Let's go ahead and put a fillet on it. Just a slight one. And one more. Okay, I'm going to finish this sketch, and now you can see that this entire thing is encompassing. We have a nice outline of this 3D mesh. This is going to be our reference point. Now what we need to do is we need to multiply that new sketch against the rest of these stars. There's a long version of this, and then there's a simpler version. Let's go ahead and we're going to hide that model. And now I'm going to go back into the sketch. Actually, before we do, let's rename this. So let's do 50 stars underscore, let's do mesh. We'll save that. And I'm going to go ahead and I'm going to hide this sketch. And what I'm going to do is I'm going to go back into the mesh sketch, and I'm going to use the rectangular pattern tool, and I'm going to go ahead and I'm going to highlight this entire all these points, and then I'm going to bring back my original sketch reference, and I'm going to use the spacing tool. And I'm going to go ahead, I'm going to drop this down, and I'm going to times this by 5. So it's going to create 5 of those star sketches. And let's go ahead and place this against our reference. And I kind of want to match where this landed. And so I think I actually hit this pretty well. Let's go ahead and we're going to save that dimension. I'm just going to copy it. So Control C. And then I'm just going to hit OK. So from here, I'm going to go ahead, I'm going to make a copy of this sketch. I'm going to hide the original, and then I'm going to do move copy, and I'm going to highlight this again. And then what I'm going to do is I'm just going to create a copy, and I'm going to use the translate. And I can move this around now, and I'm going to pull up that 50 stars original drawing again. And we're just going to bring this and we're going to place it really, really close. That looks pretty good. So I'm going to write down this dimension. Then I'm going to hit OK. And I'm going to hide that original sketch again. And then I'm going to go ahead and I'm going to use the rectangular pattern one more time. select all of that. I'm going to use my spacing. I'm going to drop this down a little bit, and I'm going to need a total of 4 of them. And then I'm going to highlight this. I'm going to Control V to the exact spacing as I used for this. So it's dimensional. I want to save those dimensions. The reason why I'm saving those dimensions is I'm going to have to do the same thing for the actual meshes. So we're going to duplicate this one, use the same spacing, and multiply this mesh by 50. From here, I'm going to hit OK. Now I'm going to rehide that sketch, and I'm going to use the rectangular pattern one more time. And now I'm going to use the spacing tool. I'm just going to bring this over. I'm going to multiply this by 6. And then I want to use the spacing of a negative 0.67. Let's see if that was, oh, not negative. Let's pull this back up. We'll have to, we'll just place it. It looks pretty close. Let's do 8.5. All right, I think that actually looks good. So we multiplied that. So we have our 50 stars, but we have a duplicate here. So that original sketch, these made it. So let's go ahead and we'll delete these. All right, so let's go ahead and finish sketch. Let's hide the original, and then let's bring this mesh back in and just make sure that we are still constrained where we want to be. So we have a really good outline of this mesh now. We multiplied it, and because of this, let's go ahead and let's export this drawing just to save it. And I'll put it in that folder, so you'll actually have this drawing file that you can reference, so you don't have to redo this. Okay, so I'm gonna hide, actually let's leave this in. I have my mesh. Now what we're gonna have to do is we're going to copy this mesh 50 times and place them on the star. So there's a preferred method and then an easier method. So I'm gonna use these as reference points. So I'm gonna go ahead and I'm gonna use the move copy tool, and I'm gonna select this body, and I'm going to do a point to point. So the original point is I'm going to use this as a reference, and then I'm going to put it right here. And I'm going to make sure I use create copy. So it essentially made just a copy of that. I'm going to hit OK on that, and now what I'm going to do now is I'm going to select these two, and I'm going to do the same thing. So I'm going to make sure select copy is good. The origin point, I'm going to use this, and we're going to put it right here. And you can see that it placed everything exactly where it needed to be. So we're going to do this a handful of times. So I'm going to go ahead and speed up the video, and we'll fill all these meshes within these stars. Okay, so I got everything positioned, and I have 50 duplicates of that one mesh file, and they're all placed within this sketch. And so I have a good vector to reference off of when I start doing my VCarve tool. As of right now, let's go ahead and we'll just hide this mesh. Let's bring back this body. And I just want to verify the positioning. So as you can see, I'm a little bit lower. I didn't put this in the correct position as far as the up and down for depth. So I'm technically below this profile. This is going to mean a lot when we start exporting this stuff into different softwares like Blender. So let's go ahead and we'll correct that right now. So let me just move all of these bodies. I'm just going to go down. I'll just select all of these. There's probably a different method that's a little bit faster to do this, but we're just going to do this like this. Okay, and we're just going to move this up. I just don't want it to touch this additional body, so let's we'll hit OK on that. And so now the real challenge is, how do I export all of these stars in this position so I can reference this bottom profile, this wave, and get all of this into a different program? And the reason why I'm pulling it into a different program is because I want to map these stars to this profile. And because right now this doesn't really do me any good at all. And within Fusion, I can't correct that. I can't map it to this profile. So we're going to use a tool called Blender to do this. And we'll go over that here in just a second. But our first big challenge right now is, how do I get all of these stars exported as one file? To do that, let's go ahead and we're just going to do a new component. And it automatically selected this as the parent, which is fine. Let's do mesh star we'll do mesh 50. And I'm just going to hit OK. And what I'm going to do now is I'm just going to select all of these bodies, all these meshes, and I'm going to dump it into this component. And I'll demonstrate why. So if I was to open up this component and say I wanted just to do this one star, it would let me save that as a mesh, as a single file. If I wanted to do, let's do 4 of them, and I right click, it doesn't give me that option. It doesn't do it that way. But if I do the component here and save as mesh, it's going to save all 50 together. And let's just double check. We'll make sure our unit is good, and that is good. So I'm going to export this as combined 50 stars. And we're going to hit save on that. So that essentially saved all 50 of these meshes as one single file. We'll let that think. It's gonna. That's a lot of stuff that's happening in the background. That's a lot of polygons, and that's kind of why I kept it under 1 million polygons when we did it originally in VistaScuplt. Okay, so now I don't need to export this. I converted this in Fusion360, so I have the STL base file of that. Okay, so let's go back to this walkthrough. We'll get out of that, and technically I do not need this component anymore since I've exported that entire mesh. I'm going to leave it in here just in case our next operation doesn't work, and I can go back and I can do whatever I need to do. But what I'm going to do is I'm just going to go ahead and hide it. So our next challenge is to use this profile and map all those stars onto this profile. Unfortunately, we can't do this in Fusion360. We're going to have to use another tool, a software tool, and we're going to use Blender to do this. So what Blender is, let's pull up their website really quick, and this link will be in the description. This is a free software, and it is extremely powerful. I do not have a lot of experience in Blender, and I've only been using it for maybe about three months now, on and off. It is a complicated program, but there is a ton of tutorials on YouTube that cover the majority of just operating the system. So we're going to do a very specific operation within Blender to achieve the result that we want. So let's go ahead and we'll transition to Blender. All right, we have Blender open. So this will be the home screen that you'll see once you bring it up. Again, guys, I do not have a ton of experience with Blender, so just bear with me. But this will be the scene that you open up into. I went ahead and just cleared everything out, and then what we're going to do is just import one, that wavy profile, and then two, all of those 50 stars under that one file. So let's go ahead and we'll import the wavy flag profile first. All of this is just defaulted, same scaling, and then let's pull this in. So it automatically placed it based on where I had it placed in Fusion360. So as I'm looking from the top down, this is what it's going to look like. And it looks pretty pixelated. I'm just going to shade smooth. Let's go ahead, since we have the profile in, let's bring in these 50 stars and see if that gets placed correctly. So I don't want to do the VistaScuplt star, I want to do the combined 50 stars. So let's go ahead and import that. And we'll give it just a second for it to load. Again, there's a lot of polygons here, so it might just take a little bit for it to go through. All right, so now what our goal is we want to project all of these models, and we want to attach it to this profile. To do this, there's a couple ways, and again, you guys are going to have to bear with me where I'm probably going to butcher this, but let's go ahead and we'll get started. So the first thing I want to do is I want to move my 3D cursor in the middle of these stars, and to do that, you can select the star, to select all 50, and you can hold Shift S and it will bring up cursor to selected and it will move this 3D cursor. Now for some reason it's not working for me, and I've tried different methods from object mode to edit mode. It just does not want to do it. I don't know why, but you should be able to do that, and it won't allow me to do it. To overcome that, I can manually put my cursor into the middle-ish of these models. And essentially that's what I did. So now when I move around, everything is centered on where this 3D cursor is. Okay, so since I have that, I'm going to go ahead and I'm going to hide my wavy flag profile, and I only want to work with these. So there's a couple different methods here to project these stars. So the first thing we want to do is we want to create a lattice, a grid pattern, and attach it to these stars. So let's go ahead and we're just going to select the stars. We're going to hold Shift A and we're going to select lattice. And you'll see that it created a box around these stars. Well, the middle of that 3D cursor. And now we're going to manipulate that. To manipulate it, we're going to go all the way to data. And depending on your view on where this is located will dictate the resolution of this box. So I only want a plane. So I'm going to set this to 1. And you can see that it deleted part of that box, and now I only have a line, a square around these. And what I want to do is I want to encompass all of these stars. Let me zoom in here. So with that box highlighted, I'm going to select, what was it? Let's do S for scaling. And I'm just going to make sure that it encompasses the majority of the star. And then I'm going to increase the resolution. Let's do 60 by 60. So you can see it essentially just made a grid. Now what I want to do is I want to basically attach this lattice to these stars. So if I select both the lattice and the stars by holding the Shift key, I can actually, before we do that, let's go ahead and make sure this is placed correctly. So the lattice right now is just below this, and I want it to be kind of intersecting these points. So right now, here's my lattice. I want to get it right around here. So to do that, I can select that lattice, I can hit G, and I can move this up. So let's put it just on the edge of the actual model. And I still want to make sure that the lattice encompasses everything. So let's go ahead and go back to the front view, and let's attach and make these parent to each other. To do that, let's go ahead and we'll select both the lattice and the stars, and then what we'll do is we'll do Control P, and then we want to select Object Keep Transform. So those basically just made them parent to each other. From here, I want to attach this lattice to these stars one more time with a modifier. So I can go to Modifiers, Add Modifier with the stars attached, and then add that as a lattice. And then for the lattice, we're going to select the actual lattice as the object. Now let's go ahead and unhide that wavy flag profile. And what we're going to do is we're going to project this lattice, because they're all attached, to the actual base profile. To do that, we're going to select the lattice. I'm going to add a modifier to that, and I'm going to use a shrink wrap. Now for the shrink wrap, there's different methods we can do this, but for the lattice, I want to select the target of this mesh. Now when I did that, you can see a lot of things just happened here, and the stars are really deformed, and it's not projected. So this method of nearest surface point is not going to work. But let's use the project, and then we can use the axis on what we're currently at, which it would be from the top down. So let's select Z, and then we're going to do a negative because it's above it. And then from there, you can see that these things are projected and they haven't deformed. It's very important that we do not want to deform these stars. So looking from the top down, it projected down to the surface, and now it is completely mapped exactly where I want it onto this wavy 3D profile. So super awesome, and I didn't lose any resolution. It did exactly what I wanted it to do. So what I can do now, since that's basically what we wanted to achieve, I'm going to hide this wavy flag profile. So when I export these flags or the stars, it's only going to do the stars itself. Let's go ahead and we'll just hide the lattice itself, and let's actually unhide the wavy profile so you guys can see this one more time. So really great method to project a model onto another model. Very cool. And you can do any kind of surface, cylinder surface. There's a lot of different techniques that you can use with this, and gives a really good result. And that's one way of doing this. If you guys have a different method, definitely let me know, and I can play around with that. But so now, since that's really the only operation we wanted to do, let's go ahead and export all of these stars that are currently mapped and get this back into Fusion360. So to do that, just with this visible, I'm going to go ahead and go to File. I'm going to export it, and then export as an STL. I'm going to go back to the folder that I was working from, and what I'm going to do is I'm going to name this Mapped Stars. And then I'm going to export the STL. From here, we'll just go back to Fusion360 because our operation in Blender is complete. And what I can do is insert that new mesh file, and we can bring it into Fusion360. So I want to use map stars. And again, it's going to take a little bit for it to calculate all these polygons. There's a lot of them because we timed them by 50. But it's going to place this directly on this mesh. All right, it just came in, and you can see it placed it exactly where I wanted it to go. I'm going to hit OK on that, and there is my projected stars onto that 3D profile. And what I'm going to do is I'm going to make sure I'll have a couple, multiple different STL files within this, the overall file of this project. So you can take this into another software that you have this profile with these stars. And you can take it to Vectric. You can do whatever you want with it. But because I have this and it worked, I'm going to go ahead and I'm going to remove this entire thing here. I don't need those, and it's going to increase my overall speed and how Fusion is reacting to all these polygons. Technically, I am not ready to really use this. So what I'm going to do is I'm actually going to delete this operation. I'm not going to delete it here, but I'm going to delete this import because we're going to do a couple more things. But before we delete it, let's just do a verification. And let's look at the projected stars and make sure they're still within tolerance, which they are. So because they were projected, all of these vectors are true. And now I can use that as a reference point to do tooling operations with my VCarve. It's going to work. And that's placed throughout this entire profile. Pretty cool stuff. Okay, so let's get back to where we need to be. We'll keep moving forward. I'm going to hide this mesh, and then I'm going to delete these map stars, and I'm going to keep it for a later operation. So let's go ahead and we'll just delete that in our history. And this will help the performance of Fusion, and then we'll bring it in later when we start doing the toolpaths for them. Okay, got everything removed. But what I'm going to do one more thing. I'm going to clean up my history. And because I already saved that combined mesh and I have it, I technically don't need all of these operations in my history. So I can actually select this, and I'm going to go just before I created that, the vectors. And I'm just going to highlight all that. I'm just going to delete it. I'm going to get it out of there. It's going to clean some stuff up. It took me back to when I just had that one star. I'm just going to go ahead and I'm going to remove that also. So now I'm back kind of, I don't have so much going on that Fusion has to reference, and it just kind of speeds everything up. Okay, so we're going to transition, and because I have the meshes, and I'll bring those back in later, I'm going to go ahead and I'm going to prep this profile, this body, and I'm going to do all the VCarve inlay operations. And to do this, Corbin Workshop created a tool that automates everything. And before any of this happened, it was very, very labor intensive to do anything like this, what we're about to go through. Because he published this tool, everything is automated now, and it's very, very fast. So the best thing we can do is let's go to Corbin's website, and in software, he has a VBit inlay for Autodesk Fusion 360. And there's two different versions of this. There's a free version and a license version. The license is just a donation to Corbin, and it can be as much as you want it to be. And I can tell you, he deserves a donation for this tool. He has done so much to make this thing work. He has hundreds and hundreds of hours dedicated to developing this tool, all to automate everything that we're getting ready to go into. I highly, highly encourage when you download this tool for Fusion that you give him a little bit of a donation. He definitely deserves it. And he's maintaining this tool. Matter of fact, the version that I just downloaded, he published that I think about 2 days ago, and it's flawless. It is super awesome. You can do 2D inlays on a flat surface, and then you can do 3D inlays on an uneven surface. It is very, very powerful. So to download it, you can go in, add it to your cart, you create an account, you download it. Once you've downloaded and extracted the file, we're going to go into Fusion 360, and we're going to go into add-ins. And once you click script and add-ins, it's going to bring you up to this prompt. And what we want to do is we want to install that plugin. So wherever you extracted that file to, we're going to go ahead and find it. I left it in my downloads. I'm going to go to the VBit inlay tool of that folder. And I'm going to select that. Once I selected that, it's going to add it into this list of scripts that I currently have in Fusion. The only thing you have to do once you're to this point is you just activate it. Now, before if he had an update to the tool, you would have to go and manually download it and do this entire process. Now, with this new updated version, if he makes an update and releases it, it will automatically update within this environment. So we just loaded the VCarve inlay tool, and what it ended up doing is it added an additional feature that you can select on. So what we want to do is we want to prep this sketch and do all the VCarve modeling and tool generation to do an actual VCarve inlay. So to do this, let's go ahead and we'll use VBit Inlay from the plugin that we just downloaded, and it pulls up this prompt, and let's walk right through this. So for the name, I'm going to do star inlay. Actually, I'm just going to delete inlay because it's gonna produce that for me. For the profiles, I want to use this mesh sketch that we created. So all I have to do is just click on the sketch, this portion. You can individually select them, but this will do all 50 at once. And then for the target body, we want to use this 3D profile. From here, we can do different options. So the inlay depth is the depth of the actual inlay pocket. I like to keep this as a deep inlay, so I'm going to put this as 0.2. I'm going to leave this automatically checked to create a plug, and then I can play around with how that plug interacts with the base model. So the inlay surface gap is the gap between the entire plug and the bottom surface, not the actual plug in the female side. So I'm going to leave this. Let's do just 0.3. I'm going to leave the base thickness, and again, this is why it was important in VistaScuplt that I knew the overall depth of that 3D model. When I put it to 0.125, this base thickness, I'm within the tolerance that I will have material left over when I start machining the plug. So I'm going to leave this as 0.25, and I'll go to toolpaths, and then I can dictate what my actual VBit selection. I can literally select a tool. I'm going to do that later. I'm going to put this as 30 degrees because I have a 30-degree VBit. Tolerances for my clearance, all that I'm not going to change, and then I'm just going to hit OK. Now there's going to be a lot of things that happen really, really fast, and you can see it's already starting to calculate. It's calculating this body and this sketch, and it's going to do all the math to do all the inlays for me, and it's going to create new bodies, and it's going to condense everything into components. Okay, it has finished. So I left that in real time so you guys could see it, and a lot of things happened here. My original body that I selected, everything is hidden, and now I have these components that were created. So the overall body, it created components for that. It also created a component of all the inlay plugs to go over that. And I can actually hide that, and you can see that it automatically cut them in to the base of the actual flag. And then it also created the plug bodies with the stars and additional stock. So essentially, and I've been playing around with trying to do this for a really long time, and depending on the model and what I was working on, it would fail because I couldn't model it correctly. The way he does this is it ends up tricking Fusion into thinking that there's additional material here when he gets into the manufacturer portion. It is very, very intelligent on how he did this. And it's just the fact that he figured that out, and then also programming a plugin to do all of this automated. I mean, it's a home run in what Fusion is going to be able to actually produce now. Okay, so that's basically the plugin tool, and now I'm ready to actually get into the manufacturer portion and do all of my tool paths to make this a reality. Okay, so before we get into the manufacturer portion, let's say we want to just kind of manipulate this just a little bit more, and we can do that very easily. And within the solid, we can go to modify and we can go to change parameters. And so basically everything within this plugin is controlled, and we can modify each one of these to kind of meet our needs. There's a detailed explanation on everything that you can adjust here. He also has a really good user manual that you can download, and it will go step by step and it will explain all of this. But if you remember, I set the inlay depth at 0.2, and you can see it here, but then you also see another parameter, and this inlay fit adjustment. This is probably one of the most important things that you need to adjust to make sure that your plug fits correctly in that pocket. And you can adjust that depending on the material that you're using, the V-bit that you're going to use, the conditions, and you can do test cuts to make sure that this fit is spot on. And what this ends up doing is this is the so-called glue gap that everybody references. I honestly hate that terminology. This is the correct terminology when you start working with fitting a plug into a pocket. And the goal is to get the bottom of that plug at a certain distance to the bottom of the pocket that you created. And for my 30-degree V-bit inlay tool, the bit that I'm going to use, I find that 0.03 is the best fit that I can get. And it's very tight, but it doesn't bottom out. And that's very, very important. If it bottoms out, you'll have gaps within your inlay, and you'll see that. So you have to play around with this, and you have to do a couple test cuts to really dial this parameter in. 0.03 is what I'm really shooting for. And then from there, I can adjust my surface gap. That was a predetermined thing. Just note that when I change anything here, it's automatically going to recompute, and it's automatically going to change this model again. So because I changed that from 0.06 to 0.03, it remodeled and regenerated this entire thing. Very, very fast, and it is just, it's so good. I can change the thickness of this model if I want to from here. And then he added a couple more things, especially with the fuzzy cleanup. That's an additional tool path that it will generate for you in the manufacturer. I haven't played around with this too much, so we're going to leave that kind of alone. But this bit angle, very, very important, because I'm using a 30-degree V-bit. It's going to chamfer at 15 degrees based on that bit. Okay, so enough of this. I did change that fit adjustment to 0.03. That's what I'm really shooting for. Okay, so I went ahead and I'm going to cut this video short. So I went through all the toolpath generations and did all the recording and the walkthroughs on that. I got to about 2.5 hours just for this video alone, and I think that's just a little too much. So I think, getting to this point is a good stopping point, and then I'll publish another video walking through all of the toolpath generations and the walkthroughs on everything you need to do to make this thing work. From the male pocket, from the clearing, to the parallel toolpathing to clear everything out, to the actual VCarve clearance, and then cleaning everything up for the actual male pockets. I did the same thing for all the flush inlays for the pockets, the parallel tool paths, everything that you need to actually VCarve inlay the actual stars in. And I think the video just got way too long. So I'm going to break this up. This is going to be an entire separate video. I'll post it here in the next couple days. And then what I'll do is I'll clean this file up, and then post that on my Patreon. So technically, this video really was basically just to take, an AI generated model, modify it in Blender to map it to the surface, and then get this thing into Fusion 360 and make it machinable. Make it to where we can do the entire manufacturing process from start to finish, get it into the garage, and actually make it. So I think we're at a really good stopping point. We're right around an hour. And we covered a ton of information and a lot of, very, this thing was a lot. And right now, because of these models, Fusion is really, it's really trying to compute this stuff. So I might try to find maybe a better method, but I think this is a great demonstration on, using very specific things in different softwares to achieve a result that you can actually use. So yeah, so what we'll do is we'll end this video right now, and then in a couple days I'll post all the toolpath generations to actually make this with, a CNC. And then after that, I'll make sure that this file is 100% where it needs to be. But I think this is a good stopping point just for the demonstration. So definitely leave comments on the video. Let me know what you guys want to see, what you're looking for, what questions. And then as those come in and I redo the videos for the toolpath generations, I'll make sure I touch on those. And then if we have to do a couple lives, maybe talk through a couple different things, we can definitely do that. But hopefully you guys stuck with it. And I'm sorry that, we kind of shifted at the very end. That was definitely not the intent, but I think you guys would get more out of, an hour-long video versus a 2.5 to 3 hour, big tutorial that it's almost impossible to sit through. So with that, I really appreciate you guys. And at the end of the day, just leave me a comment, send me an email. Let me know what you guys think, what you guys want to see, and we'll try to make that happen. So I appreciate you guys, and I'll see you on the next video. All right, thanks.